Okay, today we are going to look at public goods. Public goods, we know, have two important features. They're non-rival and they're non-excludable. This is what defines public goods. Right? Non-rival means that if I consume it, someone else can as well. Non-excludable means that I can't prevent somebody from enjoying it, right? Today we're going to talk a little bit about specifically the social marginal benefits associated with public goods. And we're going to do it around an example. All right, so for example, and our example is going to be view sheds. View sheds are scenery. They're what you look at when you looked at the mountains, when you looked at nice pastures, right? And they're often protected, right, by purchasing open space. Okay, purchasing open space to preserve views. Now, the questions that we're going to ask is going to deal with social marginal benefits. If a county or a land agency decides to purchase open space, how does that affect people? How do we account for all the benefits, all right, associated with these public goods? We're going to make a couple pretty standard assumptions, or easy assumptions anyway. We're going to assume that everyone in our story is the same, or is it their marginal benefits are at least equal for each good? So the marginal benefit of the 10th unit of open space purchased to protect goods is going to be $95. The marginal benefit of the 20th acre, okay, to protect scenery is going to be equal to $90. Right, so remember that marginal benefit of the 10th is 95, 20th is 90. Right, and everyone is going to assume to have these basic preferences or these marginal benefits. Now, how do we take those individual marginal benefits and make them into a social marginal benefit? Well, we sum. So if there's two people, the social marginal benefit, so if there's two people in the world or that we're considering, is going to be equal to the marginal benefit of the first person plus the marginal benefit of the second person. Right, so the social marginal benefit of the 10th acre with two people is simply 95 plus 95 equals 190. So the social marginal benefit of the 10th acre is 190. All right. What about the 20th acre? Do the exact same thing. So each individual has a marginal benefit of $90. So the social marginal benefit is going to be equal to 90 plus 90 is equal to 180. All right. It's just the sum. Sum of marginal benefits is the social marginal benefit. Now, graphically, this has some implications. For traditional goods, we often say that we sum across quantities. For public goods, we're going to ask, what's the value of an individual level? So for the 10th acre, right, what's the total value associated with 10 acres of land? Well, if you remember, for the first person, it was $95 for that 10th acre. For the 20th acre, it was 90. You can draw a line between those 2 points and you get an individual marginal benefit curve. All right, the second person looks exactly the same. Okay, 95 for the 10th acre and 90 for the 20th acre, so you can graph that. We have an individual marginal benefit curve that looks exactly like the first, right? The two people are the same. So how do we put that together? What does it mean to sum vertically? Well, the graph, I guess, is just a representation of the math we did earlier, right? We're just going to add them add them up. We're going to essentially stack person 2 on top of person 1, so that the social marginal benefit looks something like this. Right, for the 10th acre, remember the first person valued the 10th acre at 95. Naturally, everyone valued at 95. Okay, so we're going to go up 95 plus 95 for the second. We're going to stack that second person right on top of the first. So we're going to get a social marginal benefit of the 10th acre. Okay, you see they're the same. Of the 10th acre equal to 190. Right, the 20th acre, it's exactly the same. Remember that each person, so the first person anyway, had $90 of value or marginal benefit. The second person had $90 of marginal benefit, so 90 plus 90 is 180. We're just stacking those on top of each other. We have 180 as our social marginal benefit of the 20th, and we can draw a line. We get a social marginal benefit curve. All right, easy enough. It's a vertical stacking of the individuals. If there's 3 people, the story doesn't change. The social marginal benefit, okay, is simply the sum, now not of 2, but of 3 people. So for the 10th acre, remember each person has a $95 individual marginal benefit, so the social marginal benefit is simply 95 plus 95 plus 95 equals 285, right? For the 20th, it's simply going to be, right, social marginal benefit is equal to 90 plus 90 plus 90 is equal to 270. Right? Nothing changes with 3, which means that nothing changes graphically either. So the graphing the social marginal benefit curve is simply going to be the stacking of 3 people now. So for the 10th acre, first person valued at 95, the second person valued at 95, 95 plus 95 is 190, plus 95 is, right, 285. So the social marginal benefit curve, if we're considering 3 people, is 285. Again, for the 20th acre, we're going to stack those vertically. We're going to consider the summation across individuals, each having $90 of marginal benefit. 90 plus 90 plus 90 is 270. We have our second point on the social marginal benefit curve. You can draw a line. Right. So 3 people is no more complicated than 2 people, which means 100 people is no more complicated than 3 people. So if you have 100 people or 1,000 people or 2,000 people, the social marginal benefit is just going to be the sum of all the individuals. Okay. Since everybody's the same, it's easier to multiply than to add. So the social marginal benefit of 100 people for that 10th unit is 100 times 95 is equal to 9,500. Okay, for the 10th acre of land. And the social marginal benefit for the 20th acre is then 100 times 90, or 9,000. That's how you do across large populations. You just multiply. Right. Now what changes if instead we have numbers, as more often the case, but we have something that looks like an equation. So let's say we estimated the marginal benefit of each person and got something that was 100 minus 1/2 Q, all right, where Q is the number of acres. All right, if there's 2 people in this story, social marginal benefit is going to be the sum, but we're not going to sum quantities, we're going to sum equations. So 100 minus 1/2 Q, 100 minus 1/2 Q is equal to 200 minus 1/2 Q, or rather 1 minus Q. Right, that's the social marginal benefit curve. All right, for 2 people, 3 people is the same, 100 people, again, it's easier to multiply than to add, so the social marginal benefit for a large population, in this case 100 people, is equal to 100 times 100 minus 1/2 q is the individual marginal benefits. Right, that equals 10,000 minus 50q, 1/2 100, 50q is the formula for social marginal benefit. Right. If you wanted to graph that, you know, the y-intercept is that first term, 10,000. And you know that the slope is -50, right? The slope of the line is -50. All right, and that is how you tackle public goods.